Let me see what you guys have written. When is the stock price increasing? Some people say it's increasing in December. Some people, I saw someone said January. Some people said January to May. Are there other answers out there? January to May and September to December. Any other answers? Up in the spring and fall, okay? Okay, so stock price here. We read graphs left to right, right? So I agree, January to May. And then September to December. Agree with this one. So reading left to right, when is the Y value going up? The answer is the X values. Okay? Reading left to right, January to May, September to December. So when is it decreasing? These guys said June to September. When is it going down? I kind of would say May is the turning point. Something terrible happened at the end of May, and it's decreasing from May to September. What is the highest stock price approximately? I see somebody said May, somebody said about 85. What do you think? I have May, I have 85. Another May, another 85, 90, it's an approximation, 85. Okay, so what is the highest stock price? Am I asking when did that happen, or what is the value of the price? Am I asking for the X value or the Y value? Hi, Ben. Who do we need?
It's just a reminder for what you're saying.
Okay, thanks. Okay, highly chatty people. What is the high stock value? Is it May or is it 85? What do you think, Charles?
Stock values?
Yeah. Is it May or is it 85? What would you say? 85, yes. So I'm asking for the Y value, not the X value. I'm asking for the when. What is the high cost? The highest, whatever. And low stock price, I see 47, 10, 11. Okay, so is it 47? Oh, 10 or 11, something like that. So the lowest Y value is about, I'm asking approximation, 10, 11, any of those sound good. If I ask when did the stock price hit its low point, when it hit the low point was in January sometime. Okay, why is this relevant? Okay, so trying it again with a function with no application to it. Can you guys erase those? Try it again. When is this function increasing? Where is it decreasing?
I guess if it's 12 is the negative 9. Yeah.
It increases, like, insignificant, or like, I don't know if she wants the X value.
Spencer, you're absent.
And then from the
Sorry.
and it goes up ADB. I know that's what I'm saying, but for, yeah. And then the highest value function is
Joaquin, you are also absent.
9, 14.
Yeah.
Oh, but you're saying also.
B to C, yeah.
Okay. So,
Yeah.
Highest values are 14.
so here's the thing, some people are saying E to C, some people said -12, -3. 40, 10, 0. Okay, so I'm seeing a lot of different answers, and for what we need to do in here, when is the function increasing? So when was the stock price going up? Am I asking for X values or Y values? The X. So starting at this X, is the Y value going up as I go this way? Is the Y value going up? Yes. So it's increasing, starting at -12, and it's going up until what X value? -9. This is not mathematically correctly written yet. Do I do round brackets around them, square brackets, mix and match? Does it not matter? Okay, I will tell you what I prefer. I prefer them both round. Because when I want to say decreasing, and I'm not finished with this one yet, it's decreasing here, but then it starts to go up again from the X value of 0 to the X value of 5. So I saw these answers on some people's boards, just missing the parentheses. Yes, Tim?
So would it be correct to make -12 a hard bracket?
It would not be wrong. It's safer to leave it open, but it could be square. And the textbook that calculus uses anyway makes them square brackets, but here's my complaint about it. Where is it falling? That X value is -9 to 0, and then 5 to, what X value does it stop falling? Infinity, okay. So I don't care, well, I do, but I won't mark it wrong. Some textbooks put square brackets on that, but if you put a square bracket on, it's increasing until -9, you'll also need to put the square bracket around the decreasing interval, and I don't like that you're telling me it's true and false at the same time. It's increasing and decreasing at the same time here. I prefer the round bracket. So it's increasing, telling me the X values. Some of you guys said, oh, from coordinate E to coordinate B, those are coordinates. I need to know that you know that I'm talking about when is it going up from this X value to that X value, not to say the coordinates. So where is it increasing? -12 to 9, union 0 to 5. Where is it decreasing? Here and here. What is the highest value of the function? What did you guys get? So some people said coordinate A, which that is where the high point happens, but I'm asking for Beckham the X value or the Y value when I say what is the high value. Okay, so what is the highest Y value on here? What did you guys say? Sorry? 14? Joaquin, what is the lowest Y value? Okay, so this goes down to -infinity, and for these questions, they want it to be a number that you can write on a check. Not that you guys write checks, but can you write down the number infinity, like -infinity? So we're gonna say for these, there is no all-time low, it just keeps going. Okay, are there other high points, like less like absolute? Jasper, what do you think? Is there another like mini high point?
Point C,
Okay, what, am I asking for the X value or the Y value?
Y value.
So what is the Y value there? 4. So there's a high point. It's not the absolute high, but there's a high point. Bailey, is there another low point anywhere?
Yeah, at -3.
At -3?
Yeah, probably.
Okay. The all-time low point, or sorry, not all-time low point. There is a low point at -3. Is there another low point?
-3.
So we're not going to say infinity, but there's a low point there. Okay, in your packet, they ask for things absolute or global. That means what's the highest of the high out of everything everywhere. So the highest of the high, absolute maximum, the global maximum, 14. What is the absolute lowest this can go? I can't tell you. I can't write it as a number so it doesn't have an all-time low. But then there are things called local, and sometimes they use this horrible word, relative. Relative to its neighbors, 2 is the lowest y value around, because looking left and looking right, everything's taller. So there's absolutes and locals, and they might ask about that. Are any of you swimmers? Yeah, kind of, okay. Because Katie Ledecky, locally, she's the fastest 10-meter swimmer. She happens to also be globally the fastest in the world. So, and Bailey, thank you for pointing this out. There's another local in there. I didn't write it down. So there's locally this low value, but globally I can't say one or the other. All right, can you guys get those packets out again? There were a few pages that we didn't quite do, and I want to make sure that we do that. Yep. You don't have a packet? I don't have any extra. Can I just, so can you just get out a notebook and just write a few things? So I believe this is at the top of 5 or 6, 8, okay, or slowly off, and yes, Dylan.
I'll go for more water.
No, sorry. I'm not gonna kill you. I'm gonna dehydrate to death. All right, yeah, so top of 8. Boundedness is hopefully a simple idea. And bounded above, can you draw a picture that's something like this? Bounded above means that there's a ceiling or a top that it doesn't cross. Bounded below, there's a floor. A function has a bottom that you don't go below. Bounded and above and below, little ice cream sandwich thing. It's got a top and a bottom. What function does that sort of look like? It's poorly drawn, but sine or cosine. So bounded above and below, there's a ceiling and a floor. You're restricted. Okay? And then not bounded is any of, literally the sky's the limit. You can go any which way it wants. Good? So properties that I want you to be more comfortable with. Increasing and decreasing intervals, we're looking at when the y's are going up, what are those x values? Or when the y's are going down, what are those x values? So that's increasing and decreasing. And we might ask boundedness. Does it have a floor? Does it have a ceiling? Does it have both? Does it have neither? So this isn't in your packet at all. So given this, can you tell me these properties? What is the domain, the range, absolute min, so meaning the smallest y value of all of them, the absolute maximum, where is it increasing, where is it decreasing, and all of that stuff. So give it a try. Write it on the whiteboard, talk to each other. So, looking there, erase
Domain is X and range is Y.
I would say like negative 75
For what?
for the domain. Like, isn't it like that?
X and Y, that's 7 is Y.
Oh, I mean negative 2 and 4. And then range, like negative 75. Oh wait, we're not. It's negative 7.36 to 5. I'm different word.
Y intercepts 1.
Yeah. And then x intercepts is negative.
0.28.
Okay, and I'm gonna ask them to come up
Negative
and
0.12.
put up what they got for domain, for example. So, you get to pick which group goes up for domain. Group 11, so Sophia, Jean, Gideon, and Natalie can collectively, you guys, yeah. Oh, sorry, Cameron and Noah. Just domain, just domain. And while they're doing that, you guys get to pick the next victim. Range, group 7, which is, that's 6. No, Boaz is like, that's not us, we're 6. So Nate, Dylan, and Naomi. Okay, so can you guys come up and write up range? And pick the next one to write the y value of the absolute minimum in group 9, which that is Chloe, Samara, and Holiday. So the all-time lowest of the low. And the all-time highest of the high. Group 2, so Ashley, Tessa, and Mayuna, can someone write up what the all-time maximum is? So you guys have maximum, those guys have minimum. Okay. Now we're getting to the 2 that people aren't gonna like doing.
Should I write down?
Increasing, that's where we're gonna blame you. Who's gotta do the increasing? Group 8. So Arden and Beckham. You guys get increasing. Who gets decreasing? Group 5. So Bailey, Tim, Ella. Okay, who gets the easy one? Who gets boundedness? Group 6. Group 6, you get boundedness.
Oh wait, actually.
They're happy about that.
Can I say both?
Sure. Okay, x-intercepts, we didn't officially talk about, but you guys should know from your past math lives. Group 4, write all of the x-intercepts. Y-intercepts, who gets to do Y-intercepts? Group 10. So, Sophia, Jean, Gideon, and Natalie, group 10.
I think that's like the second.
So, okay. So if we're in a race and we want to see who's the fastest of everyone in the class, you win, Charles comes in second, and I knock out the rest of the field, and we're all last. Like, people down call, you're still locally the fastest in this room, but maybe someone in one of the other ones is faster than you. So you're not fastest in the school, but you're fastest in the school. You would be locally just nearby, you're better than all of us. Local maximum.
I think she's trying to say he had this like the second one.
Group 1.
Yeah, I feel like that's
Group 1, what's the local maximums? And the last group, group 3, what are the local minimums?
I'd just say -7. Well, maximum.
is that 1.9?
Oh, second to
Yeah, to the height.
Okay, Kevin, sit up. So, last one, local minimums, are there any? You just write with your finger. Okay. All right, so let's look. Domain, what are all the x values where we have a y value drawn? The graph starts at -2 and goes to +4. I agree with that window. Are they round or open circles at the ends, closed circles, or a mix and match? They're both closed. So I should change this to say square brackets, including -7, or including -2, and including 4. Okay? The range, the lowest y value, what is the absolute lowest y value on this graph? -7.36. And it hits that, it's colored in. And it goes all the way up to the height of 5, and it includes that. So it's easy to look at this one, but that dipped just a little bit further. So this lowest y value. Okay, the absolute minimum, -7.36. It's the y value and y value only, yes. Absolute maximum, the highest y value drawn anywhere, the 5. Yes, I agree. Where is it increasing? So they say from -2 to -0.57, I agree. Union 2.35 to the x value of 4. And you could use square brackets on those or keep them round. I prefer them round. Where is it decreasing? From -0.57 to 2.35, and they're done. Boundedness, above envelope, so both. X-intercepts, we have -1.28, 0, 0.280, and 3.660. And coordinates need to have the little hugs around them, little parentheses. No square brackets on those, it's coordinates. The y-intercept, that looks like a 2 to me, and it looks like y = 0 and y = 2. It's the coordinate 0, 1, okay? And you can only ever have one y-intercept, if any, otherwise it's not a fraction or function. Local maximums, so all-time highest high 5 is the highest. 1.9 is like local big man on campus. So yes, local minimums. So there's a low point, like absolutes right here. There's a low of -7, and that's the only one I see. So these are those coordinates which are not local minimums, they're x-intercepts, or, yeah. So the local minimum is -7. -7. Okay with that? Okay, this is in the packet. Can you guys do both of these? And if you don't have your packet, look on someone else's and see if you agree with the properties they're writing down. And compare with each other to see if you agree. It is the all-time, like, what's the highest you can go in infinity? There's no stopping, there is no max, just keep going. As soon as you try and grab it, like, what's that, you're gonna need. No, increasing is looking at the x values, reading left to right, where the y values are going, increasing where the y values are going. So compare answers, so you guys all have. You can have like in between classes, just they don't.
Yeah.
So have some answers.
Well, yeah, because they didn't give us numbers.
Like if I said this.
So do you know what you're looking for? Like what cues you're gonna look for to see what it, like which one are you trying to answer? Increasing?
I guess it would be
Okay, well, I saw you going along, looking at this, going from left to right. Are the y values increasing or not? Right here, are they increasing? Okay, so it starts decreasing at what x value? So we're coming from x this way. What's the x value all the way over here? So from the beginning of time,
Yeah.
it's dropping. Till what x value does it stop dropping? Where does it, what is this x value right here? Zero. The x value is 0. So it's decreasing from the beginning of time till 0. And then at 0, when x is 0, its life turns around, everything gets happy and rosy. Guys, yes, no? Spencer, what's the domain of this parabola? All of the numbers. Okay, round brackets on those. Naomi, what's the range? Okay, range is y values. What's that lowest y value there? This is 0. Y is 0, then -1, -2, -3, -4, -5. So the range is -5 with a square bracket to infinity. What is this, the absolute minimum? Yeah.
negative infinity.
Nope, it does not get to negative infinity. That's for what's the lowest and lowest. -5. And Jean Gideon, what did you say the absolute maximum was in this one? Doesn't have one because it's going to infinity, so we're gonna be like, nah, doesn't have one. Emmy, boundedness, above, below, both, below, it's got a floor. Right end behavior, as x goes to infinity, Boaz, where does the y value go? As x goes super duper infinity, that way, positive infinity. Charles, where is the left side going?
Also positive.
Also positive infinity. Cameron, the square root one on the other side, what do you have for domain?
-3 to
Round or square bracket on that -3?
square.
Square. Because, can we do the square root of 0? Is 0 times itself equal to 0? Let me take the headphones off. Fine. Can we do the square root of 0? 0 times 0 is 0, so yeah, should be a square bracket. What is the range? It hits -2 and goes on up. So are you guys okay with these? Tessa, you have a question look.
Yeah, why as it approaches negative infinity, how'd you type the answer that you got?
Okay, left end behavior is not the end of the picture. What's the left end of the infinite graph? The beginning of time, x is negative infinity. So what is the value at x equals negative infinity? I'm not sure, let's check.
Wouldn't it just keep going to infinity then?
Okay, well, when x is -3, or sorry, yes, -3, square root of -3 plus 3 is 0, square root of 0, cool. Now when x is -4, -4 minus 3 is -1. What's the square root of -1? Can't do it. What's the square root of -100? Can't do it. Like, so there is nothing drawn here. So what is the limit as I go super far that way? It's not there. It literally does not exist. I cannot do it. Get the difference?
Yeah.
Cool. Tim, question?
No.
Yep, homework is on Delta Math, sorry. And yesterday was checking the online textbook. How did you guys do with the online textbook? Were you all able to access it? Those of you who don't know what I'm talking about, could you please do that by today? Guys, we still have 4 minutes, so don't pack up. But I do want to start assigning homework out of the textbook, which you can, okay. I can give you a hard copy of the textbook and you can leave it at home. You don't need to drag it back and forth. But there is the online option. And if you are comfortable with using the online option, I'd rather not check out a book. But if you found it a pain to like find the right page and stuff, I can give you a book. So the point of yesterday's assignment was to see, do you know where the textbook is? Can you access it? Because I don't want to like make photocopies of a textbook that we have. Is that reasonable? Okay. So right now, is anyone feeling like they want a hard copy of the textbook? Okay. I'm a hard copy person myself. Okay. So when we have our first real do these problems out of the textbook, I'll check out a book to you guys then. Okay? So you don't have to like haul it home today when you don't need it today. What's the domain of number 4? This one up here, this picture. Okay?
Negative infinity to 0 and then 0 to negative, it's a positive infinity.
Round brackets. There's vertical asymptote there. Where we are going, we need to do a lot of things. with this stuff, and I need you to be able to recognize visually. There's this like slice, there's this problem right here. Whereas right here, at x equals 0, there is no function. What are those straight up and down lines called? What kind of asymptote? It's vertical asymptotes. And what's this one called? Horizontal asymptotes. Okay. Do you guys remember symmetry? You? No? Symmetry. Symmetry, like in art, there's symmetry when, like a butterfly, the left and the right are the same. Okay. There's also symmetry, because you guys are going to have to do things with even and odd symmetry. I'm not sure. You supposedly did this in Algebra 2, but I don't know. Even is it folds over the y-axis. Does this fold over the y-axis? And the left falls onto the right? No. Odd is if you turn it upside down, do you see exactly the same thing? Yeah. So this has odd symmetry. And it's funny, during a test, you have the technology. You guys are like, turn around. Does it work? Yay, it's odd. Okay? So we're hi Leah, how you doing? She's like, that lady crazy. So this is where we're going. And you need to be able to prove things. Sorry. Prove that it's even or odd or neither. We will start that tomorrow. All right, guys? Thanks.